Hello students, in today's topic of current electricity, very basics of temperature dependence, of resistance and resistivity, and also R through slope will be cleared through illustrations. In earlier sessions, we have discussed all these topics. These topics illustration were taken from JEE main, which you can review on CET. I will also like to say complete detailed solution of these two, that is NEET 2025 physics paper detailed solution and JEE Main 2025 maths paper detailed solution available on CET.com. You can go there and have a solution. इसी के साथ साथ मैं ये कहना चाहूंगा कि अगर अभी तक आपने CET यूट्यूब चैनल सब्सक्राइब नहीं किया एंड इफ यू लाइक द वीडियोस, इस चैनल को सब्सक्राइब कीजिए, अपने फ्रेंड्स और कोलीग्स को फॉरवर्ड कीजिए. नाउ लेट्स स्टार्ट विद द कॉन्सेप्ट एंड क्वेश्चंस. Concept is regarding temperature dependence of resistance. With rise in temperature, two effects. First, number of free electrons increases, means conductivity increases, means resistance or decreases. Second is the ions of material vibrate with greater amplitude, which in turn collision between ions and electrons becomes more frequent, means conductivity decreases, means resistivity or R decreases, right? Now there are two effects. In case of conductor and in case of semiconductor. In case of conductor, as there are very high free electrons, therefore part 2 as above is dominant. Part 2 above is dominant. If it is dominant, then resistance increases with rise in temperature and resistivity increases with rise in temperature. In case of semiconductors, as there are few free electrons, part 1 is dominant. Means rho or R decreases. Right? Rho R decreases. It means resistivity rho T equal to rho 0, 1 plus alpha T minus T0. This formula is applicable for a range of about 100 degrees centigrade, right? And T naught is between 0 to 25 degrees centigrade, right? This is regarding the temperature dependence of the resistance, right? Now, let's start the question. Question is, the resistance of thin silver wire is 1 ohm at 20 degrees centigrade. Wire is placed on liquid bath and resistance found to be 1.2 ohm. What is the temperature of bath? Alpha, that is temperature coefficient of resistance of silver, is 3.8 10 to the minus 3 per degree centigrade. Now, as we know, resistivity equal to rho 0, 1 plus alpha T minus T0. This is the temperature coefficient of resistivity or resistance. Now, as resistance R equal to rho L upon A, as temperature rises, L increases, length increase करती है, and area में depend length and area. But for all intentional purpose, L upon A is very small and can be considered as constant. Can be considered as constant. Therefore, R is proportional to rho. Therefore, RT equal to R0 1 plus alpha T minus T0. Right? T minus T0. In future, we can use this formula directly. This was explained to understand the concepts applicable, right? Now substituting the values. Substituting values. 1.2 equal to 1.0, 1 plus alpha. Alpha की वैल्यू कितनी है? 3.8 10 to minus 3, 3.8 into 10 to minus 3, T minus 20. On simplification, we get T equal to 72.6 degrees centigrade. This is the answer, right? Next question. Question is, the current voltage graph for a given metal wire at two different temperatures T1 and T2 are shown in the figure. The temperature of T2 is greater than T1. Is this statement true or false? We have to conclude either true or false, right? Now, concept applicable in this question is slope concept. Slope concept. That is m equal to tan theta equal to y2 minus y1 over x2 minus x1 equal to dy by dx at x1 y1. In this case, this is applicable. So this is theta 2, this is theta 1. For slope, theta is the angle made by line anti-clockwise with respect to positive direction of x-axis, right? This is theta 1, this is theta 1, this is theta 2, right? Now, y upon I. In this case, slope is I upon V. and resistance is V upon I. Resistance is V upon I. Resistance is V upon I. Now, as temperature increases, resistance of metal increases. That is positive temperature coefficient of resistance, right? Therefore, R proportional to T proportional to slope. Now here slope is this one. Now as theta increases, tan theta also increases. Therefore, T is inversely proportional to slope. Inversely proportional to slope. That is inversely proportional to slope. T1 over T2 will be equal to slope 2 over slope 1, that is tan of theta 2 upon tan of theta 1. See this factor, tan theta 2 upon tan theta 1. Tan theta 2 is this, tan theta 1 is 1. So this is less than 1. Less than 1. Therefore, T1 is less than T2. Check what is the statement. Temperature of T2 is greater than T1. Therefore, T2 is greater than T1. So given statement is true. Given statement is true. Right? Next question. Question is, the variation of applied potential current flowing through the given wire is shown in the figure. The length of wire is 31.4 centimeter. The diameter of the wire is measured as 2.4 centimeter. The resistance of the wire is measured to be x into 10 to the power minus 3 ohm centimeter. We have to find the value of x. This is the figure, right? Now, concept applicable here. This is EMF voltage, this is current. So, if you know R equal to rho L upon A, we have to find rho, R into A upon L, right? Now, to find R equal to V upon I, that is M, that is tan theta, that is tan 45, that is 1. This is slope, measure anti-clockwise with respect to positive direction of axis. Substituting values. Substituting values. Rho equal to R1 into pi R square, 1.2 whole square divided by 31.4. 31.4. That is pi की वैल्यू होती है 3.14 into 1.44 divided by 31.4. This goes 10. This comes out to be 144 into 10 to the power minus 3. This is equal to x into 10 to the power minus 3. So x comes out to be 144. That is the answer. Right? Now, I will request, if you are new to my YouTube channel, SETI Swift Learn. SETI Swift Learn. Please like and subscribe to my channel and press bell icon to receive updates from concept killing videos. Thank you.